Hey guys, how goes it? Sasha here from Burlington, Vermont. So I just want to share with you guys my frame design and what I think I can bring to the biking world. So when I look at bikes, I like to address them in three different categories: the weight of the bike, the cost of the bike, and the geometry and travel adjustability that the bike has to offer. So with my design, I think I've found a new way to address all three of those factors together. So looking at my design, first off, I'd like to note is the down tube, which actually is not a solid tube. It is in fact two parallel plates. And the reason why I did this is to cut down on weight and also on cost. So here's a close-up of that. You can see in between the two solid plates there are almost donuts sandwiched in the middle. One up here, one here, and down here, and of course the bearing set, which will be here, and I'll explain that later. Okay, so that's to reduce weight. Of course, you don't have the top of the tube and then the bottom of the tube. You just have the plates, and also, as you can see in the back, you can have area just CNC'd out or cut out or whatever you wish. And you can also have cool designs. It's also here, down here, and again on the chain stays. So that's to reduce weight. Now to adjust cost, however, you can see that again the solid plates. So you have solid plating that runs all the way up to here. Solid plate for the linkage assembly, solid plate, and then again solid plate for the chain stays. And the chain stays can be later welded here and then on the upper pivot. So how this reduced cost actually is because it's cut from one singular plate. You can have it plasma cut all at the same time, which is highly effective and very efficient. That's nice. Also for the chain stays, 150mm spacing, and then back to the bearing size up here. So for the chain stays, it's only 2 bends for each piece of solid, for each solid sheet of metal, and so that only requires bending and no welding for the chain stays. Of course, for the assembly in the back, for the dropouts, you will have the screws and plates for that. But very simplistic, easy to manufacture. Also, to reduce cost is you have the simple parts. So you have the head tube, bottom bracket, then seat tube, which this tube is right here is the same diameter actually as the seat tube. Then a 4cm tube from the top, and then of course the plating. So very few parts, and mostly everything from the bike actually can be made from existing tubing. Like I said, this can be cut down of an extension of the seat tube to make this part, and then weld it together. Also, for the donuts on the inside, you can do for the same with the head tube. So an extension of the head tube can be cut off and then welded underneath. So this is the frame I've come up with. I'll show you the linkage, which I'll go into geometry and whatnot, and this is how it works. It's a very smooth actuation, nice and easy. So it can go from 9.5 inches of travel all the way down to 6 if you desire, and you can fool around with the shock length and whatnot. Another advantage of the two parallel plates is up on the top mount you can have a sliding top rack for the shock length you would like. It can go all the way up to a 10.5-inch shock, which is massive and very nice. You can have that adjustability for it. Also, head tube adjustable from 63 degrees, which is pretty slack, all the way to 65. But hey, it's nice. It's nice to have that over other bikes. So again, here's the linkage, and you can also have different hole mounts. I put 2 in here for also different stroke lengths for the shocks. And again, it's very adjustable, which is nice. You can totally change the geometry, and depending on where you mount the shock, you can pull this up and change your travel and everything. So I really value that. Lastly, another little thing I want to hit on is the bearing assembly, which is really convenient and gets rid of a lot of the crazy tolerances that bikes have to go through. So basically, that can give you the full advantage of a downhill bike at a much cheaper cost due to how to make it. So for the bearing assembly, you can have You have the two parallel plates, and then you can actually have a hole drilled on the or a hole cut out on the side, like so. And then you have, imagine, like a pipe, and you can slide it right in and weld it on the outside and inside. And then you can have a small hole milled through, and then a larger hole where the bearings can be put in, and then taken out and removed. But what's nice about that is you have the exact length tube, and it goes right in here, and then welded in into the frame, and it stays there. And because it's the exact length, you don't have to deal with the welding and whatnot, and the tolerances. Of course, you know, you have to make a jig when you weld a bike. You know, if you're going to go a specialized demo or something, you really have to have precision. And whereas this, you can have precision, but at a much less expensive cost. So the bearing assembly, again, very simple. It's a tube, smaller hole milled through for the bolt, and then a larger one, not all the way through, just for the top, for the bearing inset, and then welded into the actual frame itself. And notice all the bearing pivots are actually on the two solid sheets. So again, very convenient. But yeah, that basically sums it up. I hope you like my design. Hope to hear from you guys and get some feedback, and hope you like it. Alright, adios. Cheers.